symmetry that this value would be equivalent to the value that has 5% of the area on the right hand side. Okay, so it would be equivalent to a critical value over here. Okay, so it's still 0.05 on the right, so our critical value is still the same. It's 1.691. But it's not the positive version, it's the negative version. So actually what we really have here is we have minus 1.691 is the appropriate critical value for this one-tailed test. Now our test statistic is still over here. Our t-value is still 2.366. It's nowhere near the rejection region. It's actually even on the wrong side of the center of our distribution. Okay, so this is what's known as, people might say, oh, well, it's far enough across, it's on this side, but our test was to test whether the population mean is less than €1.63. So this type of error would be what's known as a type 3 error, yeah, which isn't really talked about too much, yeah. Okay? But I mean, our decision in this case is we're failing to reject. So clearly, okay, for me to reject, my test statistic needs to be less than my critical value. So clearly, my test statistic is not less than my critical value. What I mean by that is 2.366 is not less than minus 1.691. And as such, okay, we fail to reject H0. So we fail to reject H0. There's no inference that we can make, okay? So we're just failing to reject H0. Another final possibility, okay, another final test in relation to this particular scenario might be a two-tailed test, okay. So instead of what we had already, okay, the scenario might be, instead of showing that it's greater or it's lower, maybe that what we want to do is we want to show that there's just a difference, okay. Now to show that there's just a difference, we don't mind whether we're on the right hand side or the left hand side. Once we're far enough on the right hand side or the left hand side, we could show a difference. So in this case, the hypothesis, okay, the hypothesis itself, okay, step 1 has a null position and has an alternative. I want to show that there's just a difference, so I want to show that the mean is either bigger than or less than €1.63, which means that it's not equal to €1.63, which leaves the only other possibility for the null is that the mean is equal to €1.63. Okay, our significance, the significance level is still the same. Its alpha is equal to 0.05. The test statistic is still the same. Test statistic, okay, is still t is equal to 2.366. We've calculated that in our first run of this example, okay. But now the critical values for the critical values. Now this is where things change a little bit, okay. So the critical values this time, okay, we've still got a t distribution, okay, but this time I don't mind whether the difference is on the left hand side, whether I show that it's significantly less than the hypothesized position, or if I show that it's greater than the hypothesized position. So what we do now is we take our alpha value and we calculate alpha over 2. We split the alpha in half. We put half in the right tail and half in the left tail. So I'm going to put 0.025 in here and 0.025 of the area in here. And the question now is, what's that critical value here and what's that critical value over here? Okay. Now when we look this up this time in our t tables, okay, when I go to my t tables, I've still got 35 degrees of freedom, okay. So I've still got 35 degrees of freedom. My degrees of freedom are still 34, sample size -1. But this time the amount of area in the right tail is 0.025, okay, which is the third column. So the amount of area in the right tail, yeah, is 0.025. There we go. Under 34 degrees of freedom can you see that? It's 2.032. So under with a probability of 0.025 in the right tail, we get, under triangulation, okay, we get, what did I say it was? It's 2.032. Okay. So really what we're saying is this, is that our critical values for our test, the critical values for this test, I'll do it a little bit bigger, okay, for this particular distribution, okay, that the critical value over here, okay, that this position here is 2.032, which means through symmetry that this critical value over here, this demarcation point over here, is minus 2.032. So where's our test statistic? Our test statistic is positive. It's 2.366, which is in here. Our test statistic t is equal to 2.366. Yeah. So we're still rejecting. Now, if our test statistic had been negative and over here, I would have rejected. But I wouldn't have if it had been a right-hand tail test. Okay, so my decision, step 5, our decision. Okay, our decision is clearly we have the absolute value. The absolute value of my test statistic is bigger than the absolute value of my critical value, because it doesn't matter which side I'm on. What I mean by that is 2.366 is bigger than 2.032, and as such, we reject H0 in favor of HA at the 5% level of significance. Okay, and infer, okay, that average petrol prices, well, what's the alternative? Because that's where we've moved to. We've rejected, okay? Okay? So the average petrol prices are different, okay? Different to €1.63. They could be greater, they could be less than. We actually know it's on the right hand side, so it's greater than. But in this case here, we know that the test was all about difference. Didn't mind whether it was a difference that was less than or a difference that was greater than, but that there's a difference. So you can actually see with this particular test, this was a single sample t-test. Okay, so this was our single sample t-test, and the important thing was that we actually did the whole 3 variants of that particular test. Okay, the greater than, the less than, and also just where there's a difference. Okay, so this was a hypothesis test, and in particular it was a single sample. It was a single sample t-test. The next video is going to consider a test of proportions and a single sample test of proportions. But once again, guys, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this was in some way helpful. Okay, thanks for watching. Bye bye.